Okay, good morning or afternoon, depending on when you are listening to this video. Past couple, past week or two, we've talked about minerals, and now we're starting to move into um, the different types of rocks. So, this first reading is titled Classifying Rocks. And the key question that we're looking at in this reading is how do geologists classify rocks? And again, geologist, that is a scientist who studies um, the Earth and Earth processes. So let's go down here. It says, My Planet Diary. I think this is an interesting one to read. It says, In the midst of Wyoming stands a lonely giant, Mount Moran. Stands more than 3,800 meters above sea level. If you climb Mount Moran, you will crawl across slabs of rock. These slabs form deep beneath Earth's surface. Here, great temperatures and pressure changes one type of rock into the rock of the slabs. As you continue to climb, a thick vertical strip of darker stone suddenly appears. This rock is volcanic rock. Finally, when you reach the top, you find a 15-meter cap of sandstone. This rock formed when many tiny particles were squeezed together over millions of years. So Mount Moran contains rocks that are formed in three different ways. Pretty cool. All right, here we go. Vocab, rock-forming minerals, granite, basalt, grain, texture, igneous rock, sedimentary rock, and metamorphic rock. How do geologists classify rocks? If you were a geologist, how would you examine a rock for the first time? You might look at the outside surfaces, but you would also probably use a hammer to break open a small sample of the rock and look at the inside. To study a rock sample, geologists observe the rock's minerals composition, color, and texture. Mineral composition and color. Rocks are made of a mixture of minerals and other materials. Some rocks contain only a single mineral. Other rocks contain several minerals. The granite in Figure 1, for example, is made up of quartz, feldspar, mica, and hornblende. About 20 minerals make up most of the rocks of Earth's crust. These minerals are known as rock-forming minerals. The minerals that make up granite are rock-forming minerals. A rock's color provides clues to the rock's mineral composition. For example, granite is generally a light-colored rock that has high silica content. That is, it is rich in the elements silicon and oxygen. Basalt is a dark-colored rock that has a lower silica content than granite has. But unlike granite, basalt has mineral crystals that are too small to be seen with the naked eye. As with minerals, color alone does not provide enough information to identify a rock. Here are the different types of minerals that you will find in granite. So you had feldspar, hornblende, quartz, and mica. The black specks are mica, and the pink spots are feldspar. Pretty cool. Texture. Most of rocks are made up of particles of minerals or other rocks, which geologists call grains. Grains give the rock its texture. Texture is the look and feel of a rock's surface. To describe the texture of rock, geologists use terms that are based on the size, shape, and pattern of the grains. Grain size. Rocks with grains that have a large and easy to see are said to be coarse-grained. Fine-grained rocks have grains that are so small they can only be seen with a microscope. So here example, fine grain, coarse grain, and no visible grain. Slate, thorite, and flint are all examples. So slate is an example of a fine grain rock, thorite is an example of a coarse grain rock, and flint is an example of a no visible grain rock. Grain shape. In some rocks, grain shape results from the shape of the mineral crystals that form the rock. Other rocks have a grain shape that result from a rounded or jagged bits of several rocks. So conglomerate is a round grain rock. Breccia is a jagged grain rock. Grain pattern. In banded rocks, grains can lie in a pattern of flat layers or can form swirls or colored bands. Non-banded rocks have grains that do not lie in any visible pattern. So example of a non-banded rock is quartzite. An example of a banded rock is the rock called gneiss. That's how you pronounce that word. It's a very nice rock if you ever meet it, by the way. And you will meet it, and I think you will share that same opinion. All right, origin. Using the characteristics of color, texture, and mineral composition, geologists can classify a rock according to its origin. A rock's origin is the way that the rock formed. Geologists have classified rocks into three major groups: igneous rock, sedimentary rock, and metamorphic rock. Each of these groups of rocks form in a different way, as shown in Figure 2. Igneous rock forms from the cooling of magma or lava. The magma hardens under the ground to form rock. The lava erupts, cools, and hardens to form rock on Earth's surface. Okay, so here is a key thing to remember. Not really in this reading, but magma and lava are the exact same thing. Okay, it's liquid rock. And the difference is, looking at this volcano here, this is magma. So if it's inside the Earth and not on the Earth's surface, it's called magma. The second it reaches Earth's surface, it's called lava. So again, magma is on the inside of the Earth's surface. Lava is on the outside of the Earth's surface. All right, most sedimentary rock forms when small particles of rock or the remains of plants and animals are pressed and cemented together. Sedimentary rock forms in layers that are buried below the surface. Metamorphic rock forms when a rock is changed by heat or pressure or by chemical reactions. Most metamorphic rock forms deep underground. All right, boys and girls, that is the end of this reading. Thank you for listening. Have a great rest of your day.